Hello everybody, welcome to episode number 18 of the BIVBlog, Benedict's IT video blog. My name is still Benedict Stockelbrand, and in this last episode of the network rescue/installer series, my original plan was to show you how to do some post-installation optimization and customization things with the images we've created in the previous episode. And boy, did I run into surprises there. And most of them actually, well, not that pleasant. Anyway, my original idea was to show you how to resize the partitions once things are installed on an actual physical disk. And with Windows it actually worked, so no reason to fix Windows this time because it does what it's supposed to do, or what I want it to do. But with both FreeBSD and Debian, and by extension apparently with pretty much all the Linuxes, this didn't turn out to be quite as straightforward as I thought. Now, it's still possible to do a number of extra things, and it's quite likely useful. For example, what I'd like to do in a later series is how to set up some sort of configuration management orchestration tools like Ansible, Puppet, maybe Marinette Collective or whatever. But for now I wanted to focus on those things that these tools can't do, which is really mostly resizing partitions, creating file systems and that sort of stuff. And that wasn't quite as simple as I expected. Anyway, I suggest we take a look at things, and to start with Windows, because that actually works. So here we go. Okay, so first thing, I have set up a virtual machine here, and what I want to do is first I want to resize the disk image I've got here. At this time it is 30 gigabytes in size, so we do something like dd, input file is def0, output file is hda.image, block size is 1 again, count is 0 again, and seek is 50 gigabytes. And that extends our file magically to 50 gigabytes in size. Okay, so now let's start it. And the thing to do for this to work is this. Come on. I've opened command prompt as administrator. Yes, as administrator. First thing I did was this. notepad/resize.bat. This is gonna be simple batch file to do the resize, and all we do is do disk part /s c:/resize.diskpart. Now what this does, we create a file. When it's executed, it actually repartitions the disk according to a script file, which is just what you normally type interactively into diskpart, located here. And the reason I would do this, why I do this as administrator, is because otherwise it won't get executed. So save that, close it again, and now we need the other file. And yes, we want to create that, and all we have to do is select volume c:/extend. File, save, file, exit. So that should actually work. And the next thing we should do is actually make it start whenever it boots. And there are several ways to do this. One is involving some registry hacks, which is probably the best way, because then it actually gets run when the system boots. But the most simple way to do it is to just link it into the startup folder of our standard user. And this is what I'm going to do because I want to keep things simple. What's going on there? Copy, and then it's back to the startup place, which I never really remember where it is. So here we go. Paste shortcut, that's all it takes. And that's all there is to it. And if things work out, which they rarely do, but I've tried this a couple times before, we can now shut down the machine. And at this point we should take an image. And actually we should only then resize the virtual disk afterwards, but okay, leave it at that. And we start the virtual machine again. Okay, and here we see our little script being started. And now we have a bit of a surprise in here because nothing happens. Why is that? Because there's this permission request popping underneath the window rather than on top of it. So we have to allow things to happen. And this part does some things, hopefully, and that's it. If we take a look at our stuff now, we see now we have a 50 gigabyte partition instead of the 30 gigabytes we had before. So that worked quite nicely. There are ways to optimize this. For example, we could actually add a second line to this script, or batch file, sorry, to delete the shortcut in the startup directory, but I think I'll leave that as an exercise to the so inclined reader, viewer, well, whatever. Anyway, you see, with Windows this worked out reasonably straightforward. And yes, if you want to start things before a user actually logs in, there are hundreds, if not thousands, of other ways to do this that I'm not going to get into. Anyway, this works, so why should I bother? So much about Windows. However, when it comes to FreeBSD, or even worse, Debian and Linux in general, situation doesn't look quite as nice. There are probably ways to work around this in a data center environment where you normally have mirrored system disks anyway, but that's getting a bit beyond what I want to show you and what I want to do. So I'll only show you the problems I ran into, and eventually it boils down to the question, do I really want to use images, disk images, to install machines in a sort of data center or whatever similar environment? And as far as I'm concerned, I guess I wouldn't. Windows is fine, you've seen it does the job, and installing Windows using images is tremendously fast. There's actually one more thing about Windows before I get to the Unix stuff. There used to be a tool that would let someone change the SID, the system ID of an installed Windows machine. And it used to be a good habit to run it on the first time a Windows machine was installed using an image. However, last time I checked, this tool was officially discontinued by Microsoft, given the reason that the SID is only used within the given machine. It's not used between machines on the network or so it doesn't matter if multiple machines use the same SID. I'm not entirely sure what to make out of it, because that might still cause problems if you move disks around and things, but that's what Microsoft says, and it's their stuff, so they're supposed to know and say how to do that. We have a similar problem with the Unixes as well, but well, you shouldn't have any serious problems there either. Anyway, with Windows sorted out, it's time to take a look at what's next. FreeBSD. And there's some surprises coming up there. Well, let's take a look again. Once again, I've set up a virtual machine for the job, and this time I'm not going to resize the partition first thing, but leave that for later on. Okay, First thing I want to show you is how to run things at boot time. And depending on the particular Unix or Linux distribution or init system you use, it's a file either called etc/rc.local or etc/rc.d/local. The case of FreeBSD is the first one, so let's open that. An editor, and you see it's a new file, it doesn't exist yet. So we make it a shell script. What I suggest is do something set -e. Yes, you can put it here on top, but if that means if you run it within a shell with extra options, that gets ignored. So I prefer to use a second line with a set option. And now what I'd like to do, just for starters, to show that this actually works, is a way to ensure that I get the the machine name properly set. And here's how I do it. And then echo -n, please enter new machine name colon, read this name. Okay, so this will prompt us for a new host name, and then all we have to do is put in the proper configuration file. On FreeBSD, this all goes into etc/rc.conf or etc.rc.conf/d in a separate file, but let's not go there. And what I do is echo hostname equals $hostname and append that to etc/rc.conf. So far everything is fine, and what we could do now was something like remove etc/rc.local, which is however not a good idea, because depending on the file length and where in the file this is put and how the buffering works, the shell is quite likely to complain that all of a sudden the file it is executing has vanished, because the shell, as far as I know, usually just opens the shell script file and reads a single line and does it and then closes it again, and so on. So the better way to do it is to use an exec, which means the shell script itself terminates and it runs this program instead, which runs properly and then terminates. However, there's still another thing that is not the way it's supposed to be, and that is the host name is already set. So we could actually set the host name and then continue, but just for educational purposes, let's assume that in this case we want to reboot the virtual machine. Now, we can do this by doing starting a secondary shell and giving that command to do. And no, we don't use shutdown, we do reboot. And then don't forget to do a sleep with a sufficiently exaggerated value so the system doesn't boot up all the way. And at this point we should still actually do something else. We shouldn't really delete this file, but instead move it elsewhere, like etc/rc.local. I have succeeded. So that should pretty much do the trick. One thing you shouldn't forget, change mod 755, because otherwise it's not going to work. And now when we reboot this machine, we should actually be prompted for a new host name, enter it. The machine should reboot again, come up with a new host name, and everything should be pretty much fine. So let's give it a try. And by the way, in case you wonder why I've used reboot rather than shutdown in the shell script, the system hasn't been fully booted. Shutdown sometimes behaves a bit, well, funny, to put it politely. And here's our virtual machine again, and we have to wait for it to boot. And here we go. We're now asked to enter our new machine name. New test machine. and the system's just about to reboot, and it should now come up with a new machine, a new test machine name as hostname. So here we could already see that the machine name has been properly set. The system has booted, and now let's just check that rc.local has been renamed properly, and yes, it has. So I'm not going to reboot it again to show you that the script isn't run again, because that should be obvious at this point. And this is basically what you can do and what works without any serious problem, and it works independent of the particular Unix you use. That worked fine, and it works pretty much exactly the same on all common Unixes. You have to find out the exact file name. You might have to redirect input or output or either to the console and that sort of stuff, but otherwise you can do all sorts of funny things there. You could ask for network connectivity, you could, I don't know, install extra software, create a new user account. The sky's the limit really, except when it comes to resizing live file systems, because that's still a bit of a problem. And the FreeBSD setup I'm using here is using ZFS. There's a good chance I could get it to work using UFS on FreeBSD, but in a data center environment I wouldn't want to use UFS. Why is that? Because you'd have to have some software RAID underneath to mirror disk, or hardware RAID. If you use a hardware RAID, okay, that's a different story, but on a software RAID, no, not that much fun. Not if I have an option to use ZFS instead. And so the question is, can we resize ZFS while it's actually mounted and in use? In theory it should work. Documentation, however, is really, well, scarce to non-existent. And I've tried a couple times, it worked, a couple times it didn't, and I didn't really figure out what actually made the difference between these things working or not working. Anyway, I'll show you what I've done, and if you have any ideas how to actually make this work, aside from using a second disk, mirroring things and taking the original disk, what you can do, okay, that should work. If you had a second disk, set it up as a second boot disk, blah blah blah, and create petitions and so on, and then tell ZFS, okay, please create a mirror copy of the ZFS on the second disk, give it a bigger petition, then take the original petition offline after things have resolved, resize that, bring it back online again, resolve it again, that sort of stuff. That should actually work, but it doesn't make sense. Why not? Because the only reason for using images is speed, and if I have to copy things between disks back and forth to actually get a chance to resize things, the speed advantage is gone. So it doesn't make any sense, especially with FreeBSD, where you can install it very simply. If you just set up the disks, create file systems, create ZFS pools, and then extract the tarballs from the install media on it. You've seen in the previous episode, I hope, how FreeBSD just installs tarballs basically at some point in time, and you can do that manually. No black magic about that. So at this point I'd say FreeBSD, no, not really an option. And yes, you could use an MD root, which is the FreeBSD equivalent of an init RAM disk or init RD in Linux, to actually do magic things before the ZFS pool is actually mounted. Do I want to do that? Do I want to try that? No, doesn't make much sense. One of the things I like about FreeBSD is actually that it normally gets away without using an init RD, because these things are a pain in the ass to use, and you have to remember updating them at the right point in time, and if you don't do that, all sorts of funny things happen, and it's just one of those things you don't want to touch and you don't want to get involved with. And with Linux you have to use them most of the cases, because pretty much all distributions use them, but it gets the entire boot process more convoluted and less straightforward to understand and troubleshoot if things go wrong. Anyway, let's take a look at FreeBSD ZFS and how far I got, and if you have any ideas, repeat that, let me know if you think there's a way to solve this, because I didn't find any information, and no, I'm not going to read any stupid sources, because that's not where this sort of information should go. So let's take a look again. First thing, what do we have? We have one pool called zroot, and there are two important properties it has. First, you see expand size, which says 0, so ZFS hasn't yet discovered that there's some space that's not yet used by ZFS in the partition. And there's something called auto expand, and that's set to off. What we can do is set this to on, and then we resize the disk. To do so, we power the machine off. And yes, FreeBSD 10 finally has a power off command. Now we resize the disk, and again we use, no, that's not wrong, def 0, AGA, block size is 1, count is 0, seek is 50 gigabytes. So we now have a 50 gigabyte disk installed. We start the virtual machine again. Okay, let's see what we have. ZFS pool is still around about 8 gigabytes. And now we take a look at the petitions. What's quite nice with FreeBSD is the petitioning tool. There's one called gpart, show ADA0. ADA0 again is the hard disk, and the FreeBSD ZFS installation uses GPT and a protective MBR, so standard BIOSes, funny, can actually boot. And what happens here, and we have to sort that out first, is that GPT realizes something is wrong. What's that? GPT has a copy of the petition table at the end of the disk. But now it's no longer at the end of the disk, because the disk is bigger than it used to be, and GPT notices that. So we have to create a new petition table at the end of the disk, and we do that using gpart recover ADA0. And if you take a look at the petition again, it's no longer corrupt, and we now have some 40 gigabytes of free space. And the next thing we do, and again, gpart is much nicer than anything we can do with Linux, can do something like gpart resize index 3 ADA0, resize petition number 3 on ADA0. And because we don't tell it any particular size, what it does, it just makes it as big as possible. So now we have not 8 gigabytes, but 48 gigabytes worth of space. And did ZFS find out? No, expand size is still 0, and auto expand is on. So yeah, it's not up to 48 gigabytes, it's still at 8 gigabytes. So what can we do? In case of doubt, reboot. And I haven't found another way to signal ZFS that the petition sizes may have changed. So let's reboot. And what do we get? Still 8 gigabytes in size. However, expand size is now 40 gigabytes. So at least ZFS has realized, oh, there's more space than I've had before. So, well, maybe another reboot. Okay, let's see. And we're still stuck at 8 gigabytes. nothing has changed. And if you take a look at the properties, it still says 40 gigabytes more available. I've tried that a couple days ago and eventually things worked out. But I don't know what was different at that time. So if you have any idea about this, please let me know. Come over to the forum, send me an email, whatever, because I really have no idea why it behaves kind of inconsistent like that. Anyway, the good thing about FreeBSD, something I really like, that might actually be a reason for me at some time to set up another install server that's not running on, or install system rescue system that's running on FreeBSD rather than Linux, is this Gport tool. Because with Linux, you even run into problems resizing disks. And that shouldn't be distribution dependent. It's a general problem with Linux and the tools it has to offer. So finally, let's take a look at the Debian system we've set up, right? Back to the machine. Okay, so here's a FreeBSD, Debian installation. And first things first, etc/rc.local. So you see, different than FreeBSD, there is a standard file here installed in the system. And that means if I was to do any post-installation scripting, I wouldn't just delete this file, put my own stuff there, and when it has run the first time, move the script out of the way. But instead I'd move this distribution file to a different place, put my own script there instead, and when my script has run the first time, move my script out of the way again and put the standard file back into place, just to keep these things out of trouble and make sure that things I do have the least possible impact on the system. Anyway, otherwise this works just the same. As far as I've seen, I've checked the other Linux distributions, the systemd based Unixes or Linuxes. Systemd is Linux specific, yes. They apparently all use etc/rc.d/rc.local. So with the next Debian release, which will use systemd, this file might actually move as well. We'll see what happens there. Anyway, what about disk partitions? This is where things get really ugly. First, let's take a look. fdisk dev xbda. Here are our partitions, and you see that I've installed Linux in an LVM, which is one of the options Debian offers for installation. So we have to resize the extended partitions, which holds the logical partition, and then we have to resize the logical partition as well. And for that to be possible, first thing we have to do is get a bigger disk. So we have to reboot, do our DD magic, and boot the system again. Okay, here we go. Now here's what our partitions look like. And first thing we want to do is resize the extended partition. So how to do that? Take a look at man page. And here's a surprise. These days there's also parted. The CF disk interface is nicer, but parted does much more. Not only resizes partitions, but also the file systems that live in them. Nice. Okay. Oh, not installed. Okay, let's take a look at CF disks. And wow, there is something called Resize. Maximize. Only it doesn't work. Plenty of free space. And it doesn't even show that there's an extended petition, which would be XVDA2. So doesn't help. Let's install Parted, which is not installed by default, and that means we have to do a bit of extra installation. Okay, let's go. Parted dev XVDA. So yes, there's a command Resize with a petition number, start and end. Okay. Resize petition number 2, because first we have to extend the extended petition. Start is 257 MB and it should go to 53.7 gigabytes. Okay. And there's some ugly warnings. Okay, let's check. The extended petition has been resized properly, so let's try the logical petition with the LVM. Size 5 to 57 MB and resize it to 53.7 gigabytes. Now, okay, same warning again, but this is important. Could not detect file system. So Parted doesn't let us resize the logical petition. But what else can we do? PV resize, man, physical volume resize. Resize the disk or petition in use by LVM2. Excellent. So that's what we need. And try PV resize dev XVDA 5. Great, physical volume resized. So what does it look like now? Unchanged. So that doesn't really get anything done. We're screwed here. Okay, what we could do at this point is add another petition, add it to the logical volume manager, but that's messy and it's causing trouble later on if you have to work on the disks again. So I wouldn't go that way if I could avoid it. It's quite probably a good last resort on a production system where you can't have a downtime and so on and on and on. But if you set up machines like this where you could actually sort things out beforehand, this is not the way I'd want to go. So what other options do we have? I've tried a few more things, but I'm not going to show you all of these because that's going well beyond what makes sense. Is I could have installed or could have used the MD tools to create a software RAID below the volume management, and that works, except that FreeBSD insists that there is no such thing as a one-way mirror with us, which would be exactly what I wanted at this point. Set it up as a one-way mirror, possibly later on add a second disk and then do all sorts of stuff. FreeBSD lets me do this, or ZFS, but Debian simply doesn't. And if you use the MDADM command line tool, it actually needs a special --force option to let you do this, because people think that one-way mirrors are just stupid. FreeBSD lets you, and ZFS basically says whatever you have, if you want to have another mirror, just do it. And with the software RAID on Linux, you have to say this is a mirror, and then whatever. So that's not very much of an option really. At this point, again, I decided if I wanted to do some sort of network-based installation of Debian and pretty much all the other Linuxes, I just go for some tool that doesn't use an image. I'd leave that for Windows. That's quite reasonable. I still continue to use it for my training environment, but what really got me started in investigating this. But when it comes to data centers, no, not really what I want to use. So not quite the outcome I expected, but well, was worth a try, and I've solved my particular problems anyway. So what should we do? Well, yeah, Windows and images, fine, and otherwise use Fi, Kickstart, whatever to install Linux. And as far as FreeBSD is concerned, I go back to what I've used for quite some time. Just write an installation script and use an install rescue system that is actually running FreeBSD. Choose gpart, create petitions, populate them using gpart as well. Nothing very spectacular about it. Create a ZFS pool, extract the tarballs from the installation media in there, and that's it. Takes you day or two to get all the details right, and of course if you want to do this in a way that it's generic and works for pretty much everybody, it doesn't really work, because eventually you reach a point when you're with a tool that half the people complain, oh, this has got so complicated and I can't really use it, it's just got so many features and options that I don't need, I just don't get things done in a reasonable time, and the other half complaining, yeah, but I just need this one more feature that's still missing. And at that point, my personal preference is to just find a way to install things the way I need and ignore pretty much everything else, especially things that I'd normally do with the configuration management tool like Puppet, which I've used so far. So, well, again, not quite the outcome I've expected, and I hope you still found this useful one way or another. Hope you enjoyed it. If you have any ideas, comments, questions, different approaches to the entire issue, I suggest come over to the forum at www.stepladder-it.com/bivblog/18, and yes, it's repeated on the final closing slide as well. And if you watched this on YouTube, enjoyed it, give it a thumbs up, please, 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 pretty please. And in any case, hopefully see you again soon with a completely different topic again. Okay, so much about the install and rescue system. Hope you enjoyed it. Hope to see you soon. Bye.